Hi student, in today's lecture we see exercise 3.5 question number 2. In last lecture we see question number 1. So first question is there, x is equal to u plus 1 upon u square and y is equal to 2 raised to u plus 1 upon u. Then we have to find the value of dy upon dx. So first our function x and y are both parametric functions of u. So we differentiate these two functions with respect to parameter u. Differentiate with respect to u. So simultaneously we differentiate these two functions. So first, what is the derivative of x? So derivative of x with respect to u is dx upon du is equal to d by du into u plus 1 upon u bracket square. And here dy upon du is equal to d by du 2 raised to u plus 1 upon u. So treat this as a x. So it becomes x square. So what is derivative of x square? That's 2x. So this function can be written as 2 into u plus 1 upon u raised to 2 minus 1, that is 1. So power is 1 into multiply the derivative of u plus 1 upon u. Now this term dy upon du. Now treat this function as a raised to f of x. This is a raised to f of x. So what is derivative of raised to f of x? We know that derivative of raised to f of x is raised to f of x into log a into multiply the derivative of the function. So right here 2 raised to u plus 1 upon u, right, as it is. 2 raised to u plus 1 upon u into log a, that means here right log 2 into multiply the derivative of function. What is function here? U plus 1 upon u plus 1 upon u. Now 2 into right u plus 1 upon u as it is. Now find the derivative of u plus 1 upon u with respect to u. So what is the derivative of u with respect to u? Here is 1. Now what is the derivative of 1 upon u? Derivative of 1 upon u with respect to u. We can't find the derivative of this 1 upon u. So we write this 1 upon u as u raised to minus 1 and consider as a power function. So by power function, the derivative of this function minus 1 into u raised to minus 1 minus 1. So minus u raised to minus 2, that means minus 1 upon u square. So derivative of this 1 upon u is minus 1 upon u square. So this is a dx upon du, say equation number 1. Now we find the derivative of 1 with respect to u. Now write this as it is into log 2 into again derivative of u with respect to u 1. Again derivative of this 1 upon u is 1 upon u square. Therefore say equation number 2. This is our equation number 2 and we have to find the value of dy upon dx. So by parametric function theorem, therefore by parametric function theorem, dy upon dx is equal to dy upon du divided by dx upon du. Now put the value of dy upon du. So we can write from 1 and 2. 2 raised to u plus 1 upon u into log 2 into 1 minus 1 upon u square divided by dx upon du. So what is value of dx upon du? That is 2 into u plus 1 upon u in bracket 1 minus 1 upon u square. Now consider this x as a first equation and this y as a second equation. So what we have to show here? X is equal terms with u raised to into log 2 divided by 2 into u plus 1 upon u. This is our answer, but this answer will not match with our book. So we simplify this answer. So look at this x and y. So this is a value of y. What is value of y? 2 raised to u plus 1 upon u. So instead of this 2 raised to 1 upon u plus 1 upon u, we write 1. So the numerator becomes 1 into log 2. Now look this term. X is equal to u plus 1 upon u bracket square. So here only u plus 1 upon u square. We first simplify it. X is equal to what? U plus 1 upon u square. But here only u plus 1 upon u. So we take square root on these both sides. So after taking square root, we get root x is equal to u plus 1 upon u. So u plus 1 upon u, which is the value of root x. So instead of this u plus 1 upon u, we write root x. So our answer becomes y into log 2 divided by 2 times root x. Right from given, we put the values of x and y here. So we get the value of dy by dx is equal to y log 2 divided by 2 root x. Now we see second question. X is equal to under root 1 plus u square and y is equal to log of 1 plus u square. Y is equal to log of 1 plus u square. Now again x and y both are functions of u. So differentiate with respect to u simultaneously. Differentiate with respect to u simultaneously. So first the derivative of x is dx upon dt. Now treat this function as a root f of x. So what is the derivative of root f of x is 1 upon 2 root f of x. So here we write 1 upon 2 root 1 plus u square into d by dx of 1 plus u square. Again here dy upon du is equal to, again this has a log f of x. So what is derivative? 1 upon f of x. So 1 upon 1 plus u square into take the derivative of 1 plus u square. Now write these functions as it is. 1 plus u square into, what is the derivative of 1? That is 0. Plus derivative of u square is 2u. So here we get 2u upon 2 root 1 plus u square. Now this 2 will get cancelled. So remaining terms are u upon under root 1 plus u square. So equation number 1, that is the value of dx upon d. Now find the value of dy upon d. Write this 1 upon 1 plus u square as it is into, again derivative of 1 is 0 plus derivative of u square is 2u. So here we get 2u upon 1 plus u square. After simplifying, give the number dy upon d. That is the value of dx upon du and this is value of dy upon du. So again write, we have to find dy upon dx. So write a parametric function theorem, dy upon dx is equal to dy upon du divided by dx upon du and put the values. And put the values. Therefore dy upon dx is equal to 2u divided by 1 plus u square upon u divided by root 1 plus u square. So we write this as 2u upon 1 plus u square into root 1 plus u square divided by u. So this u will get cancelled and the remaining terms are 2 root 1 plus u square upon 1 plus u square. Now here we write, if we have 2, then this 2 is equal to root 2 into root 2. So instead of this 1 plus u square, we write root 1 plus u square into root 1 plus u square. Upon root 1 plus u square into root 1 plus u square. Now this root will get cancelled, and so answer is 2 root 1 plus u square. That is value of dy upon dx. Therefore the answer is 2 divided by under root 1 plus u square. Now question number 3. Differentiate 5 raised to x. Question number 3. Differentiate 5 raised to x with respect to log x. So these type of questions are asked in the exam for 1 or 2 marks. Differentiate 5 raised to x with respect to log x. So consider these as a two functions, as a u and v. So here we write u is equal to 5 raised to x and v is equal to log x. So we have to differentiate u with respect to v. That is to find du upon dv. We have to find du upon dv. So how to find du upon dv? So first find du upon dx, then find dv upon dx, and write du upon dv is equal to, in this time, dv upon dv divided by dv upon dx. So first differentiate this u and v with respect to x. Now here parameter is x. Differentiate u and v with respect to x. So derivative of u, du upon dx, that is d by dx of 5 raised to x, and dv upon dx is equal to d by dx of log x. That is du upon dx is equal to 5 raised to x into log 5. This is a raised to x. So derivative of a raised to x is a raised to x into log a. Here base is a, so we write log 5. And dv upon dx is equal to derivative of log x is 1 upon x. That is equation number 2 and equation number 1. We get equation 1 and equation 2, and we have to find dv, du upon dv. Therefore, again we write by parametric function theorem. Therefore, by parametric functions theorem, dy upon dx is equal to, here we have to find du upon dv. So we write du upon dv is equal to du upon dx divided by dv upon dx. So from 1 and 2, what is value of du upon dx? That is 5 raised to x into log 5 divided by dv upon dx, that is 1 upon x. So this will get x into 5 raised to x into log 5. So derivative of 5 raised to x with respect to log x is x into 5 raised to x into log 5. This is question number 2. Now we see question number 3. Question 3. If x is equal to a into 1 minus 1 upon t and y is equal to a into 1 plus 1 upon t, then show that dy upon dx is equal to minus 1. Now we have given two functions with parameter t, and we have to show that dy upon dx is equal to minus 1. So here both are functions on parameter t. Therefore we differentiate these x and y with respect to t. Differentiate with respect to t. Simultaneously we differentiate these x and y. So derivative of x dx upon dt, that is d by dt of a into 1 minus 1 upon t, and dy upon dt is equal to d by dt of a into 1 plus 1 upon dx upon dt is equal to the derivative of a is as it is and derivative of 1 is 0 since it is constant. Now in first example, we see the derivative of 1 upon u, that is minus 1 upon u square. So here derivative of 1 upon t is minus 1 upon t square, but here is 1 minus sign. So this minus minus will become plus 1 upon t square. Equation number 1. And here d1 upon dt is equal to a into derivative of 1 is 0 and derivative of 1 upon t is minus 1 upon t square. Equation number 2. We get value of dx upon dt, d1 upon dt. So again write my parametric function theorem. d1 upon dx is equal to d1 upon dt divided by dx upon dt. So what is value of d1 upon dt? A into minus 1 upon t square and dx upon dt is a into 1 upon t square. So here a will get cancel, t square will get cancel, minus 1 upon minus 1 is equal to minus 1, hence it is true. That is d1 upon dx is equal to minus 1, which we have to prove. Now second one example. If x is equal to 40, x is equal to 40 divided by 1 plus t square and y is equal to 3 into 1 minus t square divided by 1 plus t square, then show that dy upon dx is equal to minus 9x divided by 4y. Then show that minus 9x upon 4y. So again these two x and y both are functions of parameter t. So here to find dx upon dt and dy upon dt we have to use quotient rule because there are two terms in the form of u upon phi, and we know the derivative of u upon phi, that is phi into derivative of u minus u into derivative of u divided by phi square. So here we use the quotient rule of derivative. So first we differentiate only x. X is equal to 40 divided by 1 plus t square. So differentiate with respect to t. Differentiate with respect to t. So derivative of x with respect to t is dx upon dt is equal to, write this b as it is, 1 plus t square into d by dt of 40 minus write 40 as it is into d by dt of 1 plus t square divided by 1 plus t square and whole bracket square. So write this 1 plus t square as it is into derivative of 40 is 4 minus write 40 as it is into derivative of 1 plus t square is 2t divided by 1 plus t square bracket square. So here we multiply this 4. So 4 into 1 it becomes 4. 4 plus 4t square minus 8 40 into 2t, that is 8t square upon 1 plus t square square. So here we get 40 square minus 8t square, that is 4 minus 4t square upon 1 plus t square. So we take common 4 from this. So in bracket we get 1 minus t square upon 1 plus t square and write this as a equation number dx upon dt. Now we have to find the value of dy upon dt. Is equal to d by dt of 1 minus t square divided by 1 plus t square. So we take 3 common from this 2 because this is a constant. So 3 into d by dt of 1 minus t square divided by 1 plus t square. Right? That's a constant. So use quotient rule here. Write 1 plus t square as it is into write derivative of 1 minus t square. 1 minus t square minus right here 1 minus t square as it is into take the derivative of 1 plus t square divided by whole thing divided by 1 plus t square whole bracket square. Now this is the constant as it is, right? 1 plus t square as it is into derivative of 1 is 0 and t square is 2t but minus 2t minus 1 minus t square as it is into derivative of t square is 2t upon 1 plus t square whole bracket square. Right? 3 as it is. Multiply this by 2t into 1 so minus 2t minus 2t cube. Right here minus sign as it is. So this term will get 1 into 2t and so minus 2t. Again this minus minus it become plus and 2t square into 2t that is plus 2t cube upon 1 plus t square. Now here minus 2t cube and plus 2t cube will get cancelled. So 3 into minus 2t that is minus 4t upon here we get two values dx upon dt and dy upon dt and we find dy upon dx by using parametric functions theorem. So dy upon dt that is minus 12t upon 1 plus t square whole bracket square divided by 4 into 1 minus t square divided by 1 plus t square whole bracket square. So these same terms will get cancelled and these 4 3s are 12. So it becomes minus 3t divided by 1 minus t square. Say question number first, that is value of dy upon dx. But we get dy upon dx is equal to minus 3t upon 1 minus t square. But this is not matched with this dy upon dx. So we simplify this minus 9x upon 4y. So minus 9x as it is and put the value of x. So what is value of x? So x is given here 4t upon 1 plus t square and is 4 as it is into value of y is 3 into 1 minus t square divided by 1 plus t square. So 1 plus t square will get cancelled. 4 again this 4 will get cancelled and 3 is 9. So the remaining terms are minus 3t upon 1 minus t square. Question number 2. Therefore from first and second, therefore from equation first and second, dy upon dx is equal to minus 9x upon 4y. Hence it is true. Now the third question is there. If x is equal to t log t and y is equal to t raised to t, then we show that dy upon dx minus y is equal to 0. So x and y both are parametric functions of t. So to differentiate x, differentiate with respect to t. So derivative of x is dx upon dt is equal to t into 1 upon t plus log t into derivative of t is 1. So dt will get cancelled. 1 plus log t. That is value of dx upon dt. Say question number 1. Now given y is equal to t raised to t. We can't find the derivative of this t raised to t because this is a function raised to function. So we apply logarithm on both sides. Taking logarithm on both sides, therefore log 1 is equal to log of t raised to t. Therefore, by exponent law of logarithm, we write t into log t. Now, we differentiate with respect to t. Differentiate with respect to t. Therefore, derivative of log y is 1 upon 1. Derivative of y is dy upon dt. So, again we use product rule here. T into derivative of log t is 1 upon t. And log t into derivative of t is 1. So, dt again will get cancelled. 1 upon 1 into dy upon dt is equal to 1 plus log t. We want only dy by dt. Therefore, y into 1 plus log t. And what is value of y? That is t raised to t. Therefore, t raised to t into 1 plus log t, since it is given. Therefore, by parametric functions, d1 upon dx is equal to d1 upon dt divided by dx upon dt. What is value of d1 upon dt? T raised to t into 1 plus log t from 1 and 2. And dx upon dt is only 1 plus log t. So 1 plus log t will get cancelled, and the d1 upon dx is equal to only t raised to t, and which is value of 1. T raised to t is the value of 1. Therefore, d1 upon dx minus 1 is equal to 0. Hence, d1 upon dx minus 1 is equal to 0. This is our last question. So here our exercise 3.5 is completed, and in next lecture we see our next point, derivatives of second order functions, or this one is also higher order derivatives. Thank you.